Where you mix two things to get one thing. A certain way to do something. Very descriptive way you want.
Okay, interesting way of putting it. Mr. Munoz?
Kind of like a equation.
Okay. Yeah, okay. What, if you kind of do the combination of the two, what can change in your recipe? Or what can change in your equation?
Like the way you do it.
Okay, the numbers that you put in it. So, in a formula, why is it different than an equation? So, it is a special equation, but why is it a special equation? What's the difference? Why do we say a formula is useful in science or in any other terms that we're going to use a formula? Well, when we do an equation so far, we've said something like this, right? 4x plus 7 equals 14. Right? And what do we know that we're solving for? The x, right? Because really there's only one variable in the whole problem, right? So this is an equation. One, because it has a variable, and two, because it has an equal sign. So when we talk about formulas then, we're still going to say that it's an equation, but now we're going to say that it's an equation that has multiple with multiple variables. But in a sense, we know what each variable is talking about. So if you thought about a formula, does anybody know a formula right off the top of their head? Bless you. Again, maybe from science, maybe from math, that there's multiple variables, but you understand what each of those variables means. Hold back.
It would be like,
But there's no equal sign. What are you going to say, bud?
like, 2x plus 7 equals 14, like that. And then 14 plus 3x equals 15. So on.
Good try, but no.
Uh,
Anybody else want to give a guess?
Would the formula be like E equals MC squared?
Perfect. So a formula is something like G equals MC squared. Does everybody kind of know what that is? This would be a science one, right? So do you know what the parts mean, Miley? What does E mean in that case? Maybe, maybe not. She just heard of it before, right? She's seen the Albert Einstein poster, and he says, yes, you know, E equals MC squared. But this would be an example of a formula because this means something. And each of the letters means something. Okay? Right now, we're solved here for the letter E, but we could solve this for any of those letters in the problem, right? If I asked you to solve for M, how would I get M all by itself here? What's happening between M and C squared? Multiplying. So how would I do it? I would divide, right? And if I would divide by C squared on one side, I got to do that on the other side. So my C squareds would end up canceling each other out, and I'm left with M equals E over C squared. This would be the exact same formula, but now it's solved for a different letter. So really, we can take a formula and solve it for any of the letters in the problem because each of the letters stands for one specific thing. Does that make sense? Okay, so the formula that we're going to talk about today is D equals RT. Ever heard of this formula? Anybody? Not even in science? Really? Alright, so this is the distance formula. Or one of the distance formulas.
Distance, rate, and time.
When you do the distance formula here, okay, what's really important from here on out is when you start talking about formulas and writing them down, it's really important that you write it down the right way. Meaning, notice my letters in my formula right here, they're all lowercase letters. They need to always be lowercase letters for D equals RT. So if you write this as capital D equals R capital T, those don't signify the same thing. Yeah, they're the same letters, right? But because it's a capital D compared to a lowercase d, it could mean a totally different formula. Okay, so you really have to be careful and write the letters as they should be. So, what does each letter mean? Well, D is some kind of distance. How do I measure distance? What are ways of measuring a distance? Miles, feet, yards, inches, meters, kilometers, okay? Some kind of distance, right? What does R mean?
Rate.
What is a rate? How fast you're going, right? So another way of saying rate is speed, maybe, right? When you say a rate, how would you say a rate? Ms. Kramer, you said that it was how fast I was going. So my rate would be measured in what? Okay? But when you say a rate, we usually say that this is miles per hour, right? Feet per second, right? A really important one is meters per second. When you start talking about gravity in science, will be meters per second. But a rate is usually something per something else. And so obviously when we write miles per hour, we usually write it as mph. But remember, we can always, the per can always be shown as a little slash. So this could be miles per hour. All right? And then what's T?
Time.
Time, right? And when you're talking about the time and you're talking about the rate has some kind of time in it, right? This one had hours, this one had seconds, this one had seconds. When you're doing these rates, the time should match that rate. So if it is miles per hour, then you should be talking about time in hours. If this is meters per second, your time should be considered in seconds. Okay, so if they're not both the same, then you got to convert one into the other. Make sense? Okay? So, if I asked you to find the rate here, what would I do if I wanted to have R as my answer? By T, right? So if I divide by T on one side, I'd have to divide by T on the other side. So rate is really distance over time. But essentially, we're using the same exact formula. Does that make sense? So the three letters are still the same, but rate is distance over time. Distance is rate times time. But we're still using the same variables. Okay? So, here we go. See what we can do here. If you travel 135 miles in 3 hours, what is your average speed? Okay, so what am I going to write? Meaning, what variable do each of the numbers signify? If I have 135 miles, which one is that? Is that a distance, a rate, or a time? It's a distance. So I'm going to say 135 is equal to, what is my rate?
3 miles per hour.
Do I know my rate?
No.
No, I don't know my rate. So I'm going to write my R. Or if you wanted to use S for speed, that's fine. Rate and speed are the exact same thing. And then what does it mean if I take RT? I'm multiplying, right? So I'm going to take R times T, but in our case, what is T?
3 hours.
3 hours, right? So, here, look, what do I have right here? I have a distance, and right here I have a time. So, how do I get my rate? I'm going to divide by 3. But listen, this is 135 what? Miles, right? And this was 3 what? Hours. So, do the miles and the hours cancel each other out when I divide? No. So, that tells me at the end when I have my rate as my answer, it should be written as what?
Miles per hour.
Perfect, right? So, how many miles per hour are we going? What's 135 divided by 3?
45.
45 miles per hour. Okay? But do you see why the label ends up being what it is? Because it didn't cancel out. So like over here, when we do rate times time, we're going to have a time on the bottom of our distance, and the times will cancel out because they're diagonal to each other. And they're left then with a distance. Make sense? All right. So, look at the jet one. How long will it take a jet to fly 5,200 miles at 650 miles per hour? So what am I looking for? I'm looking for time. Perfect. I know my distance. 5,200 equals. What was my rate?
650 miles per hour.
650 miles per hour, right? And we don't know our time. So now, same exact thing, but we're just solving for a different variable, right? So what is t? How do I find t? So what do I get? What's 5,200 divided by 650? Everybody realize that when I do this division right here, I can just cancel out those zeros at the end? Right? Because they each have a 0 in them. So what's 520 divided by 65? How many times does 6 go into 52? How many times does 6 go into 52?
No.
Let's try 8 times, right? Because 9 times 6 is what? 54. 54. What did you say? Are you sitting my Colbeck for too long or what? What's 65 times 8? 8 times 5? 0, 4. 8 times 6?
48.
Plus 4?
40.
Holy cow. You guys are the elite, remember?
Yeah.
We can't multiply and divide. So, here we go again. What's my label?
Miles per hour.
What's my label? Hours, right? Because watch. On top we had a what? What was 5,200? Distance, and in my distance was in what? Miles. On the bottom, we had what? This was 650 what? Miles per hour. Well, if I flip this over, and we don't really understand this concept yet, because we haven't talked about reciprocals and such, but when I flip this over, it would have been that, and look what happens. My m's cancel each other out because they're in diagonals, so what's left over? The hours. Now again, that process right there is way ahead of where we're at right now, but that's the reason why that we end up. And again, we're doing a story problem, so every single story problem should have a label at the end. Okay? Do we understand how to put it into this formula right here? Everybody okay? All right. Next one. We talk about the perimeter of something. So have you ever heard of the perimeter of something?
Yeah.
It's the what?
What it takes around it.
Perfect. So, the distance around the outside of an object or shape. When I do the perimeter and I'm going around the outside of my shape, what operation am I going to do with my lengths. I'm going to add them up. So this is a sum, right? So when I do this now and I'm doing my addition, my answer always needs a label. Because basically this is kind of just a glorified story problem. But when I have this now, we should have a distance, right? We've already talked about distances, miles, inches, feet, you all said all those, right? When I use my label though at the end, it's still just that label. So it is just feet, I don't know what S, I don't know why I was going to say seconds. Meters, miles, inches, all of those are labels, right? And they don't have any exponents. So, we are going to concentrate today on rectangles. What's a rectangle?
Four-sided shape.
Okay, four-sided shape, and what's true about that four-sided shape?
Two of the sides are longer than the other.
Okay. Anybody else want to chime in? What else?
All the sides are equal. No, not two of each sides are equal. Like they are.
We just said that.
Hold on, breathe. All right, you're on the right track. What do you want to say about it? How would you describe which sides are equal?
The width?
Okay, so how would you describe that? Is the width is what to the other width?
Equal.
Yes. And how do you know where they're at?
They're on the side.
Shorter.
It's parallel to the other width and the other length. They're parallel.
And what does parallel mean?
They will
They
never
never
cross.
cross. The lines never cross.
Okay, and they're what to each other? Okay, they're equal in length, but how would you describe them from one side to the other? They're parallel, but they're on what sides?
Opposite.
Opposite sides. Perfect. So, they're on opposite sides. So, is this a length or a width? This is a length? Does it really matter? Can a length be shorter than a width? Can it? Why not, right? So, but most of the time we kind of think about the width as being the shorter side, right? So we're going to show this as length, length, and then width and width. And if I was doing the perimeter of this, I could write it as a formula, right? P equals what? What'd you tell me I have to do with all those letters? Add them all together. So I could say W plus L plus L. Or I could simplify it now because we know how to simplify and say what? Okay, W times 2 or?
W squared.
No. W squared and 2W are totally different, right? Because we're not taking W times W, we're taking W plus W. Big difference, right? So we want to say 2W plus what? 2L. So, hey, look, formula, right? That's why we're doing this. Look, different variables, but we can find everything. So, here's my perimeter problem. The perimeter of a rectangle is 60 feet. Okay? The perimeter, so maybe we should say this up here too. Perimeter shown, or the symbol for perimeter is what? Capital P. Okay? So when you write your answer, you should say capital P is equal to. Not little p, capital P. Alright? So the perimeter, they tell me in this, is 60 feet. Well, what the heck? They already gave us an answer, right? They gave us the answer. But they ask us, find the length. So they tell me that the width is 9. So if the width is 9, not only is it 9 over here on the left-hand side, but it's also 9 on the other side, right? So how do I find L?
Add both 9s together, which is 18, and then subtract 60 by 18, and then divide your answer by 2.
Perfect. So, two different ways that I can do this. Basically, just think through the process or fill it into the formula, right? What is capital P? 60. What is W? 9, right? Or it's going to turn into 18 plus 2L. So basically, you're going faster than the formula because you already understood the formula. So what's 60 minus 18? 42. 42 equals 2L, so what's L?
21.
All right, question of the day, what's my label?
Feet.
Why?
Because that's area.
Because it was in 60 feet already. Exactly right. Okay, any questions there? So that's using another formula, right? So last but not least, then we talk about the area of a rectangle. So what's area mean? Okay, but what does it mean in general?
The whole thing. Like if I got a rectangle, you find out the surface area.
No, difference, because you just used a different vocabulary, right? So what's the area of an object? I'm finding the what of the object. In a sense, you're kind of right, but the surface area would mean the what of the object. Don't say the volume, now you're finding volume. That's a whole other thing, right? What's the surface area? The surface area of my Kleenex box is the outside. It's the amount of space that I have on the outside of my object, whatever object it is. So what's the area? Is the area three-dimensional? No. So we don't need a box now to find area. So we're going to find the area of an object. Well, what does that mean? What's the area?
Length times width.
Now, that's how you find the specific area of a rectangle. But what's that? What's length times width mean? Because the perimeter was the distance around the outside, right? The distance on the inside?
No, the round space it takes up.
Boom. So the area of an object is the amount of space on the inside of the object. See what I'm getting at? So that's still different than surface area, right? Still different than volume that Caleb wanted to find too. Right? Volume and surface area go to three-dimensional objects, like our Kleenex box. Area and perimeter, we're talking about two-dimensional things, flat surfaces. Okay? So now, you've already said it, but what's the area of a rectangle?
Length times width.
Equals length times width, and its area is my A, a capital A or a lowercase a? Capital. This is really important. Got to have a capital A for area. We'll have something else for little a later. Okay? Another way that you probably need to start thinking about this is area could also be for a rectangle. B times H. What do you think B times H means?
Base times height.
Base times height means the exact same thing as length times width. Now this is more geometry stuff, but this is important that you start relating them to the same thing. Okay? So what's the main difference though? Now we're going to multiply my length and my width instead of adding them together in my perimeter. So my answer still needs a label, but because I multiplied my distances together, my feet times feet, what does my label need to be? Squared. Okay? So answer needs a label, and it has to be squared. And again, why is that? Because I'm multiplying two things together. So feet squared, inches squared, whatever we're talking about, squared. Anytime that you, from here on out, you see something is squared, you think that it's going to be an area. Okay? So find the area if the length is 14 feet and the width is 6 feet. So area equals, if my length is 14 feet times my width, which is 6 feet, and I'm just putting the label in there so you know it, you don't have to put the label in there when you're doing the math. What's 14 times 6?
84.
Here we go again. 84 what?
Feet squared.
Feet squared. So again, from here on out, if you don't have the label, half wrong. Okay? So the difference between that one and this one right here, now we have the area of a rectangle is 40 square meters. Its length is 8. How do I find the width?
Divide.
I just divide, right? Now here's the question. So when I have this one right here, I said 40 is equal to 8W, basically, right? So Grace said divide. So W is equal to, well, that was a weird one. 5 what now?
Meters squared.
Meters definitely, does it have to be squared?
No,
Why?
because it's not an answer.
This is an answer.
Well, I mean, like,
Is my meter squared in that answer right there? Why? You can't just say no, you gotta know why.
Because it's a one of it's the width.
It's a width, right? It's not an area anymore, right? We started out, so here, look, we started out with these being meters squared and these being meters, but we divided 1 meter out, so what's left over? Just 1 meter. So if you end up with a width or a length, then it is just going back to the label. Okay? And then they might ask you to do both perimeter and the area of the same shape. But again, that's where you have to slow down a little bit and think about the label at the end. Okay? So if it says the perimeter, again, I'm coming back here, I'm adding all the way around, and my label is just the distance. If they ask me the area, now I'm multiplying, and my answer has a label that is squared. See the difference? But it's really, really important. Okay? Questions here?